Alright, so this is what you're going to be writing in your lab notebook. The title of the lab that we're going to be doing is Determination of Iron 2 by titration with permanganate. So that's the title that you want to write in your table of contents, and you're also going to want to make sure you title this for the new blank page that you're going to be using for this lab. The question that we're going to be answering with this is how much iron basically is there in our sample of ore. So what you're going to do is, what is the percent by mass of iron in an unknown? Now this time we are going to be doing the unusual step of actually writing out our materials. The materials for this particular lab are very critical to its success, and it's the fact that we have to use glass, and it's because permanganate is a strong oxidizer and can cause plastics to actually react with it. So you don't want to end up with melted plastic and a fire on your hands. So what we're going to do is we're going to make sure that we're only using glassware. And the glassware we're going to be using is we're going to be using a burette for most of it. And there's a small piece of plastic in the bottom of a burette that will actually not react with the permanganate because it's designed as such to not do that. And then of course you also have a funnel to put everything into your burette, and you want to make sure that this funnel is glass, not plastic. The chemicals that you're working with is you're going to be working with potassium permanganate, and you're also going to be working with your unknown. And I'll just tell you what your unknown is actually going to be. We're going to actually symbolize it as FAS, and FAS is going to be iron 2 ammonium sulfate. We're also going to have to use a thermometer because one of the chemical reactions we're going to have to do has to actually occur, believe it or not, between 60 and 90 degrees Celsius. Another thing that we're going to be using is a Bunsen burner to provide heat because the chemical reaction has to happen between 60 and 90 degrees Celsius. And let me think here, there is also one other critical piece of equipment that we're going to have to use, which is oxalic acid. Oxalic acid is actually going to be used to ID or identify the standard concentration of permanganate that we're working with in this lab. So now what we're going to do is we are going to get to the background information. The background information is going to be critical for the success of the lab because there's two different reactions you're going to have to do. The first thing you're going to have to do is you're going to have to standardize your permanganate. The reason you have to standardize the permanganate is because you don't know the exact concentration you're using. Now, I've set it to be close to 0.02, but you need to be more precise with that. So to standardize it, we're going to do a chemical reaction with oxalic acid. And that chemical reaction is going to look like this. This is the formula right now that I'm writing out for oxalic acid. The 5 is because I've already balanced this ahead of time. And then it's reacting with the manganate, or permanganate, sorry. And it's going to happen in a acidic solution, so it's with 6 hydrogen ions. And then the products for this reaction, you're actually going to have some carbon dioxide, manganate, and water. So that's the first reaction we're going to be doing, and that's purely to figure out what the concentration of permanganate that we're working with. If you have enough space in your lab notebook to write this as all the reactants and then this as all of the products, that's best. Now, number 2 is once we figure out what the concentration of the permanganate is, we're going to do a reaction with the iron. And this was actually our warm-up where we went ahead and balanced this redox reaction. We're going to react our iron with the permanganate under acidic conditions. And what's going to happen is the iron is going to lose an electron. So it's going to go from Fe2 plus to 3 plus and produce water as well. So again, reactants and products. And what we're going to do is we're going to try and identify how much grams of iron was actually in the sample that we measured out. And we're going to do it by knowing how much permanganate it took to fully react with the iron. And of course, that's a 1:5 ratio. So now that we have this background information about both of these reactions, let's talk about the procedures. So the procedures that you're going to be writing down, let me get out another piece of paper for you guys, is we're going to start off with the standardization. And please do write these procedures down in your lab notebook. So standardization begins with filling the burette with the permanganate solution. And you're going to know the permanganate solution very easily because it's going to be a dark, deep purple. So you might want to write that down, that that's going to be purple. Okay? After you fill the burette with the permanganate solution, what you're going to do is you are going to measure the mass of your given oxalic acid. So I'll measure out a sample of oxalic acid, and you're going to place in flask. So you're going to put it in a flask. After you place it in the flask, you're going to add, and it doesn't have to be exact, approximately 100 milliliters of sulfuric acid. And the concentration of your sulfuric acid is going to be 1 molarity H2SO4. Then you have a solution where you have the oxalic acid dissolved in the sulfuric acid. What you want to do is you want to make sure, you want to really make sure that the two are dissolved together. So the oxalic acid, make sure oxalic acid is dissolved. Then what you're going to do, after you have done that, is you are going to begin titrating between 60 degrees Celsius and 90 degrees Celsius. So you're going to use a Bunsen burner to heat the flask that has the sulfuric acid and also has the oxalic acid. You need to keep it between 60 and 90 degrees, and then you're going to measure the amount in milliliters of permanganate to turn solution pink. It's going to turn it pink and stay pink. And that's going to be what we call the endpoint for this reaction. Now, those are just the procedures, believe it or not, for standardizing the permanganate. We're going to continue to write out these procedures when you come back to class. If you have at least this much written down, then what we can do is we can actually write out the rest of the procedures, and then you can understand a little bit more about the steps that we're following and how to be safe, and actually figure out the amount of iron in the sample that we're working with. If you guys have any other questions, please see me during tutoring.